Good afternoon, students. Today we are going to see a small demo about how the computers are working through by the software called CPU simulator. You can download from as the online CPU simulator. Once it is downloaded, it is look like we have to see this is having that is a OS CPU simulator. That is having that is a CPU simulator. CPU OS simulator 7.550. Have to install by CPU OS simulator. Once start installations, after I get the installations, okay, we can see from what is the process. Okay, once installation done, we can able to see some demo for that. Additional two number in the assembly level languages. You can see from step by step. Okay, for step by step, you can directly open by that simulator. You can give them as the CPU simulator. Once you can open here, it is loading. That is all the process. You can able to see from as the one GUI mode will become through by as the Java software. The developing from as the Java software CPU simulator. Once it is coming here, we can able to see on by there is the three things are available. Okay, you can see. Okay, you can see here the avatar is a CPU simulators are available. CPU simulator. This avatar is CPU instruction in memory. RAM is available and also the programs are available. Instructions are available. Optimization program controllers are available. Program list is available. Here you can see by the pipelines are also available. Cache memories are available. And you can see from as the in microprocessor what are things are required. Program counter, stack programs, the given method is a branch instruction, and the flag registers are the zero flag, non-negative flags, and the instruction registers. What is current instruction, and memory address register, memory data register, everything is available. Okay, we have it to choose from as it is a registers are available, general purpose registers, depending upon the register selection. Suppose selecting by the 8 register, you can able to change the entire thing. You can able to compromise the 8 register operation, only can able to come here. Before we have the 32-bit registers are available. Now if you want to start the first process, first of all you want to assign by some name for that. You can give them as a name called about the demo, and you have to give them as a base address. You want to give them as a one. Once you have to add by the first one, automatically once adding by demo with the address is one me, you can able to come the here. Suppose if you assign from as is a 10 me here address start from as starting address be as a 10 address you want to start. Suppose if you want to remove this one, you can able to remove it. Now, if you want to one start, it is the program list to be created. Then go to the instruction tab. Once go to instruction tab, you want to perform as that is additional two number. For that, we have that is the in the particular the CPU. We have that is the data transfer instruction. The assembly level language instructions are available. Data transfer, arithmetic instruction, and control transfer, comparison, IO, logical operation, miscellaneous instruction tabs are there. First of all, what you'll do here, you want to perform this additional two numbers. You have to do two tasks want to perform. First, I have to perform as the move operation. First, I have to give the particular thing. When I click by the move, it is opcode. You want to give from a source operand you want to give it. Source operand you can give from a directly by some value or register value you can apply. Directly apply from as the register value you can apply here. And which register want to be as coming in the command from here. We are not using as a normal register. We have to go from as the or not register want to be applied. Okay, they having the execution clock cycle as it is a one clock cycle we decided, and you can give from whether is a new instruction you able to give here. Once click from as the new instruction be click here, automatically come from as that is a we are given the address equal to 10. From the address we have that is the labels are given the 00, move 05 to the R00. Next what you'll do there, you want to move from as a one more register value, we can assign from as a 10 here, and move from as the R1 register. Once give from as R1 register, then I have to be given here. Second instruction will become. The first instruction take from as a 0 address. Second instruction take from as a 6 bytes want to be taken. 6 bytes are taken. Next, you want to add from as a one more instruction want to be add here. In this one, you perform the arithmetic operation. Once perform the arithmetic operation, we have to give that is a register value. Which particular operation want to perform the arithmetic operation, we have to give them as a R0 or R1. Once click that is particular operation, they want to add from as that is the source register as it is the R0. They having this destination register having 0 1s are there. So these two, what is the value 5 and 10 you can able to move here. Then add these two register value mean 5 and 10 will be added. Result will be available on the R0. Once it is the program is stopped, okay, we want to move from as it is a control transfer instructions are available. Okay, you want to apply from as a start halt. Usually what happen when I want to load the program, you want to give the address having the LDA. Okay, you can give from as a halt command. Once given the halt command, our code is be as a completed. For that, when I want to save this all the code, what are settings are done from as our end, we can able to save from as the program only. We can give from as a demo dot. In this particular CPU simulator, we can save the file name as it is a dd dot triple d I saved. Once it is saved, have to be as a save that one. I have to remove is all the programs. Okay. Next, I want to load this one. Simply go to this load command where you can save the file ddd. Once click the particular thing, automatically your program will become here. Look like as a backup is available. Once it is done here, before you want to start here, you want to see what is the existing things are available for here. Initially, I mean there is a menus are available as a CPU pipelines are available. Here, I mean there is a so pipelines are there. Initial pipeline, there is all values are nothing. Simply as nothing is available. All are empty. When I come as the data cache also, it is having empty for data cache also it is having it is empty. Here we can see from as it is a the important thing is the demo is there, and also here having the program controls are available, whether executing the instruction by step by step, otherwise instruction by instruction. CPU we can able to see, and also here there is the optimization also available. When I apply from as the optimized techniques, you want to apply with optimization. Once it is done from as the all, okay, we can see from as the 8-bit registers only available here. Totally 8 registers only available. So what you'll do here, first you have to create by all the program, make enable by the result tick marks, then start from as the steps. Once start with the steps, here they're showing by the CPU 0, runtime take from as the 0.5 into 34 milliseconds are taken. The stop by the instruction from as the breakpoint come from as the address equal to 06. So what is here? 0 is started and up to the system be executed, take from as the 6 address will be as added, so can able to stop one by that is a stop, take in the process. Okay. Next one start from as similarly executed by the second line. You take from as the second line want to be executed. Okay, second line want to be executed. You take from as the 0.507 second only. Okay, next what happened executing by the third line. Third line want to be executed. Take from as it is the 0.709 milliseconds only taken. Finally, I want to execute the halt command. You can able to see from as the entire process you can able to complete from as the 0.1 1 minute 706 seconds are taken. Okay, this from as a process. You can see from when I running this code, you can able to see on the register data is there. R0 having the 05, R1 having the previous 10 is available. After pump by there is the addition operation. R1 must having the 15s are there. And compromise it is the so pipelining is done. In this pipelining, okay, you can able to see on this pipelining what are the instructions we are given from here. You can able to see on from as data are there. Pipelining is nothing about is the overlapping of this execution time. Here after is a fetch, decode and read operation, execute, write backs are there. Whenever if you want to apply by the pipelining asserts are there, structural asserts problems are coming, or maybe the data assert problems are there. For that the given notification will be there. I mean, this data assert problem here, untold assert problem will be able to show here. Total number of class take from as 24 class cycle taken is that means the 5. 5 means the 1, 2, 3, 4, 3, 4. 4, 5 is the 20, but it taken as the extra seconds to be taken by fetch and also compromise the decode, then having read operation, then having some delay is empties are there, empty cells, then compromise is a execute operation, then compromise is a the right result will be there. So in this one, you are able to see from as the how the pipeline stages are coming here, how the pipeline stages are coming there. Next, if you want to compromise the cache, when you want to compromise the cache, we have to see from the 3 instances are available. One is data, another one is instruction. Now go to the instruction one. What are instructions we are passing here? Data will be available, and also during the process, when I want to start this proceeding, start with the proceeding, we want to be as the loading some data. When I want to move the one data from here, you can able to show on the which data I want to start, whether I have to hit or not, because initially having the 0 nothing is available. After the having this 0 some data is available, then 1 want to be accessing and maybe hit, and also this also add from as R0 and R1 mean having the hit will be there, halt also hit. So having the 2 hits are there, all are having misses. Miss me this new data set, the data not available on by the present on by cache memory, it's available on secondary memory only. You want to load the particular data to this in the particular cache memory, it is called from as the hit will be there. Cache, hit and hash miss will be there. Whenever processor asking some data about from this cache, okay, when asking about the processor, from the cache is available, right? It is be available mean hit. If not available mean miss. So what will do the miss mean directly go from as a secondary our RAM memory. The RAM memory has the any data is available on the corresponding address, we can able to load. If you're not available now, go to secondary loaded devices like hard disk and IO device you want to go through. After the data is available, the particular data, the address is loading on the cache memory. Next time if you want to searching on some data over there, it cannot go from the travel by that much time. Directly you want to be loading the corresponding address for that. Whenever we come there now, you can send the mail for data. This from as the one example from that. From this here, you can able to see and from there is a what is the process between this all from the cache memory. Here we can see here once it is running the code now, you can able to see from as the here. And one more thing is also available here. The execution units are available. Execution units. Suppose click from as the instruction. Okay, automatically this execution unit will be taken place from here. First come from as a fetch. Fetching as this from as that is the opcode. This is one operand. This from as the another registers are available. So to perform the decode operation, they have to give from as the move is the some operand value, immediate value, and give from as that is the R double zero is nothing about the operand 2. This is having the operand 1. Result is available on by 0 5 will be there. After execute the one, the value we can able to store and by the or not having the fine. Suppose I want to know, I want to change this value because I want to use the same value. I want to increase by the 8. Okay, for that when I want to see them as a new instruction we come here. When I want to perform this particular instruction by here, fetch and decode execute time, the value had to be modified from here. Once it is executed now, we have the value equal to 8. After executing by the step-by-step process, okay, if you want to run the code, entirely take from as a 7 6 seconds only taken. Now if you want to run by the next one and the next one, once the program going for stop that one. So the result want to be updated from as a 10 plus 8 equal to 80. So for this, if you want to apply here, suppose I want to apply some data is a different value. Suppose I want to edit by value. Suppose to move 10 is there now. Instead of 10, what will do here? I want to apply from a register value. I give from as the R0 value. Then I have to apply from as a R1. Instead of give the R1, I can apply from some other value. Okay. R1 values are given. Once given the R1 and R1 value, here we not possible to give there is a once it is executed, R0 values are there, but R0 values are there. But here you want to instruct from as the one more instruction required, move some data value you want to pass here 16 with having that is the some R2 register. Okay, in this one we can able to change. Okay, we can able to move up this instruction you can able to move up here. So you can see here the first instruction execute from as the R not, then I have to come from as the move and having 16 want to move here. Now what will do here, I want to perform the addition operation here. Add. Suppose here I want to change into the add with having there is the R not with having there is the R2. Okay, then newly can able to modify here. This instruction can able to delete here. Okay, you can delete here. Now what we'll do here, until now executing by the R not, when I come from here, it won't execute the code. Suppose if you want to run this code here, you can see here what the result is there. 8 plus 16 become as it is the 8 plus 16, it become as it is 24 be required. But here it is not because we are not selecting this particular process, so that is not executing. Suppose once selecting the process, one short term as running this process, you can able to execute the code. You can able to update the value. Okay, but here as the 8 plus 16 mean we require the value must be as the 8 will be there. Next step we want to be loading on by 16 want to be loaded. But once it is loading at 16 now, it is having there is a 16 will be loaded. After that, when I want to add from as the R0 and R0 and R2 want to be added, 16 plus 8 want to be as updated. So R0 value having the 24 will be the 24. Okay, 24 will be there. And after having the program go for this halting. This from as some simple example about that how the is the working here. What is that is the pipelining and what is the step-by-step process we can able to see on by the graph also. In this one we can able to see on by there is a what is the flow will be the flow instruction whether given the five pipeline instruction or 3 instructions code we can able to see on from here. Thank you.